Welcome back. Thank you very much for sticking around. My name is David McFeeters-Crone, and I'll be talking today about partnerships with the Manufacturing USA Institutes. I want to thank you again. It's great to be back at the Federal Laboratory Consortium annual meeting. I've done a variety of different roles within the labs, mostly as a contractor. I started my career working in MIT's technology licensing office and also working with FFRDC that's present there. Then I worked for a now defunct organization within NASA doing regional technology transfer. And then I did a pretty long stint working as a third party to TechLink and some of the other partnership intermediary network companies. But most recently, I've been working within NIST's MEP program as part of the Oregon MEP to act as a program manager for a program they've done called the Embed program, where they've taken where they've taken MEP representatives and placed them close to each of the 14 Manufacturing USA Institutes with the desire to bring in small manufacturers, making sure that they stay engaged in the process to cover a lot of the things that Dr. Copan mentioned earlier today. I'm fortunate today to have representatives from two of those institutes, the Robotics Institute, which is based in Pittsburgh, and the Smart Manufacturing Institute, which is based in California. And without further ado, I'd like to sort of continue on. So I use this slide a lot. Often I use it in terms of helping small companies engage with Manufacturing USA and also engage with the Federal Laboratory Consortium facilities. But today I'm doing this in reverse. My belief is that there's some opportunities for your labs and, more importantly, your stakeholders to engage with the Manufacturing USA Institutes in order to help them with their commercialization, to enable them to forward faster. And as often been said, even though there's been a lot of change, there are certain things that stay the same in this game, and that is very much a contact sport. But I'm here to tell you that there are some great opportunities out there for your stakeholders, and by those I mean your licensees, your creative partners, and any other contractors you may deal with on a regular basis. So as I mentioned, there are 14 Manufacturing USA Institutes. They are funded mostly by the DoD. There's a smaller number funded by the Department of Energy. And lastly, there's one institute focused on biopharmaceutical engineering funded by NIST itself. There's too many things to talk about in this one slide, and at the end there'll be some contact information and some other ways to get access to each of these laboratories. And again, within a lot of time, we really only have time to talk about the two that I've mentioned before. So the institutes, as a general rule, are trying to focus in this gap, the valley of death that we always hear about, moving technologies through from TRL 3 to TRL 7. Different labs have a different focus. They each have a different area of technology that they're working at. But generally speaking, they're trying to move technology on the earlier stage through to the later stage. And I think that bodes really well for some of the commercialization projects that are being done within the laboratories themselves. So one of the ways that you can think about the Manufacturing USA Institutes is like a cloud R&D situation for these stakeholders. They need an additional resource to be able to find answers to some of the problems, maybe some of the unanswered problems that exist with the technology as they come out of the laboratory, to move them through some of those critical stages. So that's just one construct. The other one that I think is important to note is that the opportunities that are available for your stakeholders are more than just technology. It's really a network. It's the idea of being able to leverage the work that's being done, the basic research that's being done at the laboratories themselves, and bringing it forward, exposing them to larger companies, to other smaller companies, being able to get additional market research on what might be useful. If you're at all familiar with the I-Corps program, this is an excellent place to go seeking out some of those interviews for your stakeholder companies to be able to move the technology forward, to understand where it might be useful in some other way. In addition, if you have new technologies, I believe that these are some great places to talk to the management of these institutes and find out if there are some opportunities within them. And in fact, within the last 10 minutes, I was approached by Robin from NIST with a new laser-powered sensing technology, and they've asked me to get in touch with the AIM Photonics Institute, which is out of New York. So if there are any others out there for either Jay or Haresh or any of the other institutes, I strongly encourage you to stick around and ask questions. So again, One of the things that is also, I think, imperative is that the MEP network has representatives essentially in every single state. Now, each facility, each center, each MEP center does have different representatives, and they have different focus areas themselves, but they're on site, they're in place, they are excellent resources for you to do sort of entry-level information on companies. If you're looking for opportunities for contacts, they are talking to lots of small manufacturers and have the ability to start some conversations for you. Again, I'm a contractor to the Oregon Manufacturing Extension Partnership, as well as a liaison for the Manufacturing USA Institutes. There are 13 others like myself who are also liaisons to the institutes, and I would strongly recommend that you find a way to connect with them. For those of you who aren't familiar with the MEP program, there's a whole range of services that we offer for small manufacturers. And by small in this case, we're using the SBA definition, which is 500 and below. Generally speaking, we do tend to focus on the 100-person and below type of companies. These sorts of organizations are really across the gambit, everything from ideation and licensing and new product development through strategic sourcing. Lean process management is an area that the MEP network is famous for, through to strategic sourcing, and then end-of-life succession planning as the companies are transferred over to new generations or to acquisition opportunities. So again, I'll leave you with this slide before I introduce Haresh. The focus of this presentation is to give you some ideas of opportunities that are out there within the Manufacturing USA Institutes. They're funded at $1 billion over the next 5 years, and they've been sort of ramping through that time frame. Each has a different segment. Many of them are being renewed. In fact, the hope is they'll all be renewed for if not another 5-year term, 2- and 3-year terms moving forward. So the opportunities are there. Each of these institutes has individuals present to be able to talk to you about what your needs are. But if you have any issues or you need some overview information about that, I would be happy to take your phone calls, your emails. I have a table out there with a small amount of information and a number of my cards if you miss me. I'll be on the FLC app, so if you need to find my contact information. And I have a number of friends throughout the audience who know me well, including John Dement, so I'm hoping that you'll reach out to one of them. So as I told my colleagues, I'm really just the appetizer. These are the individuals who are going to provide the meat of this presentation. So first up is the Smart Manufacturing Institute, and I'd like to introduce Haresh Malkani, who is the CTO of that institution.
Welcome to SESME, the Smart Manufacturing Institute, manufacturing's voice of innovation, powering the smart manufacturing movement.
Well, I know audio works now, so that's great. Thank you, David. Just by way of introduction, my name is Haresh Malkani. I'm the CTO of SESME, the Smart Manufacturing Institute. I think the logo that you see here is a recent rebranding, so if you go on the website, you still probably won't see this. It's going to be up in a couple of weeks. My background has been mostly in technologies that kind of make up smart manufacturing. So when you talk about things like sensing and process control, process modeling, analytics, that has been my background for the last 30 years. Before I joined SESME, I was with the Alcoa Research and Development facility in Pittsburgh. So there's a connection here between the two speakers. And as of last March, I joined SESME as their CTO. So glad to be here. Thank you for being here. Before I start, how many of you have actually heard of this particular institute? So that I can, okay, maybe a few of you, yeah. Okay, great. So what I'll do is I'll just begin with a high-level video that kind of introduces the institute. It's just a 1-minute video, so it's not something that you'll fall asleep on, hopefully. Let me get here.
Welcome to SESME, the Smart Manufacturing Institute, manufacturing's voice of innovation, powering the smart manufacturing movement. As an energized ecosystem, we are unique. We work tirelessly to drive industry's productivity and competitiveness ahead in the United States. We are built upon the network of our dedicated members' active leadership and engagement. At SESME, we see a way forward, and we recognize industry's need for a clearer, more actionable vision for the smart, data-driven future of manufacturing. Growing manufacturing's productivity, sustainability, and competitiveness. We seek to revolutionize manufacturing by obliterating the barriers for rapid change and innovation. Manufacturing of tomorrow is an exciting space where the innovators, the trailblazers, and the makers all thrive, and where our brand is truly home.
Okay, so SESME as an institute, like David mentioned, it's one of the 14 institutes that's been put up by the federal government. Each institute has a focus area that has been given as part of their charter. For us, our focus is around improving energy efficiency in manufacturing through technologies that are known as smart manufacturing technologies. And like I said, it's sensing, control, modeling, analytics, and platforms. The institute was founded in 2017. We are getting started. We had a bit of a pause for a few months, but the institute is now under the auspices of UCLA as a parent institution. And we are just about to launch off several projects this month worth about $16 million in funding. Again, it's a public-private, $140 million is the total funding available for the next 5 years, out of which 70 comes from the Department of Energy. And like David said, there are other institutes that have funding coming from Department of Defense for comparison. The $140 million here is just a drop in the ocean for the $150 billion that Walter talked about in terms of the investment that the federal government is making. We don't have a product to sell. I mean, we thrive on our network of members that bring in the expertise and the technologies that make up smart manufacturing. So at the end of the day, we are all about networking, as David said. We are all about bringing an ecosystem together that helps us develop those technologies. One of the things that we're trying to do is a theme called democratizing smart manufacturing. And to that effect, our membership model has been dramatically changed as of just a month ago, actually, where we'll be enabling a lot many small, medium manufacturers to come and join our ecosystem. So that's the charter going forward for us. And again, we are again, like I said, the ecosystem is going to actually deliver the technologies and help proliferate smart manufacturing technologies through our manufacturing systems in the country. So we, as an institute, we've developed a roadmap with 4 integrated pillars. 2 of the pillars that are on the right-hand side are around technology. The first one is about enabling technologies. So when you talk about solutions that make up sensing and control and modeling and so on, those are all enabling technologies. But then the other one on the bottom right is the smart manufacturing platform. So it's not just about developing those technologies, but how do you make those technologies available and accessible for everybody in the manufacturing space in a cost-effective manner. So our charge is to develop that platform where people can plug in their technologies, people are able to use those technologies at a very low cost. And on the left-hand side are the 2 other pillars that are non-technical, but equally important. One is around workforce development. A lot of these institutes have that as a pillar, and that's a great thing because we can actually cross-communicate across these institutes around workforce development. And the other one is around business practices. So these are all the four pillars of the roadmap. And what we've done in the roadmap is to identify near-term, mid-term, and long-term opportunities that exist in this space. So you're welcome to go on the website and look at the roadmap, but you'll see the flavor of what we have in the roadmap. And the idea is to take that roadmap and then launch off projects that will help address the elements of the roadmap in the 5-year time frame that we've been given and beyond. So the idea about democratizing smart manufacturing falls into basically 3 buckets, right? Talk about democratizing knowledge. So this is about getting the entire manufacturing ecosystem the ability to learn about what smart manufacturing is and how it can be applied to the manufacturing processes. How do you train your workforce to become ready for this Internet of Things and the Industry 4.0 that you hear about, right? All the more fourth industrial revolution technologies. So that's the one piece. But the idea there is to how do you make it simple, how do you make it addressable so that you're looking at the workforce at all different levels, the people who touch and feel the process, the people who are at the engineering level and the management level, the people who are in the C-suite in these companies. How do you bring the level of knowledge up? The other one is around enabling technologies and platform. I briefly talked about this. So how do you get the actual technologies that help manufacturer become smart? And how do you make that accessible and available? That's all about democratizing technology. And the last one is making it collaborative to innovate, right? So this is where I talked about the ecosystem. We're not going to be tied down to a specific technology or a specific vendor, but develop an ecosystem where everybody can play together and everybody are able to use the technologies that are developed. So that's the theme around democratizing. So what do we mean? Many of you may or may not be familiar with what smart manufacturing actually is defined as. And at the very fundamental level, it's essentially the use of information to make smart decisions, right? So, and the information has to be the right information at the right time, delivered to the right people or the right machines, so that those decisions can be made, either by humans or by machines, right? That's essentially what it is. So when you hear the word Industry 4.0 or the fourth industrial revolution, it's about how you leverage information to make things smarter, right? So what are the building blocks that make up? If you think about a manufacturing process, the first thing that occurs in terms of making it smart is to obtain information from it automatically, right? So that's all about sensing, right? When you install sensors on your machines and your manufacturing flow paths, you get the data from that process. But that's not enough, and the reason it's not enough is that if you put a thermocouple that measures temperature somewhere in your process, unless and until you know where that temperature was measured, when it was measured, how it was measured, and how it relates to the product or the manufacturing process, that piece of information is just a number, right? So developing a context around that data becomes very important, and that's the piece on the left-hand side, contextualization. And once that is done, then you have information that becomes actionable, right? So that's a very central theme of what we're trying to accomplish. And then once you have the information, then you can route that information multiple ways. You can use it back into your control system to control your process better. You can do some advanced analytics on it to understand why things are happening. You can develop some intelligence based on modeling and predictive analytics and so on to understand when it could occur next and how you can prevent that from happening or have more of that happening. So that's all the right-hand side of the picture. So if you go from left to right, you're going from a reactive mode to a more proactive mode, and then looping it around for your manufacturing process. So these are all building blocks of smart manufacturing. And one of the things that I will mention here for my colleague who's from the Robotic Institute is that automation is sort of a foundational piece, right? So when you think about a process, when you think about sensors and control, that's all about automation. Robotics is all about automation. So they go hand in hand. So as you hear from him later on, you'll try to, you'll see how that kind of connects up. Sorry, one more point I wanted to make here was that the arrows between these blocks are equally important. And this is all about information that needs to flow between these systems at a level and in a manner that's not taking you weeks and weeks and weeks to kind of put stuff together so that information can be transferred between these, right? And contextualization becomes an important piece for that. So what we've done is we've looked at how do you make that happen, right? How do you connect all of these pieces together in a fashion where you have a platform that enables multiple players to play into the ecosystem? So at a very base level, the first ability is the ability to connect to your manufacturing systems, connect to your data sources, right? So that's the bottom layer of this picture. And there are tons of solutions out there. There are tons of vendors who come and give you the solutions to connect back into your machines, right? The next piece, as I said, is contextualization. This is where a lot of subject matter expertise needs to come in. So the data that's coming from your machines, from the people on the manufacturing shop floor, it needs to be put into context. You know, what does it mean? And this is where a lot of subject matter expertise comes in. So if you're trying to do this for a aluminum parts maker versus a automotive assembly line versus an aerospace manufacturer, the context of that data changes, and you need people from those manufacturing entities to provide that context. Right? Once that is done, that information that is collected can be sort of modeled and stored and made accessible for consumption, right? And the consumption then happens through what we're calling a marketplace of applications, right? So if you have a person at one of the universities who's the brightest person who has a machine learning algorithm that's just out of this world, that person can now bring that application back into this ecosystem and make it work for the manufacturing applications, right? So it's all about how do you define the use cases, bring these applications into a marketplace, and then let the users use the applications with the data that's coming from the manufacturing floor, right? So it's a pretty critical piece of this particular system platform. So how does the Institute actually work with these enabling technologies and the platform? So if you look at this diagram here, on the left-hand side, it's all about the development of these technologies. And you look at the ecosystem, whether it's the academia, whether it's the manufacturers, whether it's the technology vendors, they help develop the fundamental technologies that are essential for this, right? In the middle is the platform. So these technologies make their way into the platform so that they can be used by our manufacturers, right? But that doesn't mean that you need the platform all the time to make those technologies available. You can actually take the enabling technologies and have a technology transfer between that and a manufacturing user, right, without the platform as well. So you can take those pieces and make them work. But it's essential that as you drive it through the platform, we have a feedback loop that says, as you begin to proliferate these technologies and as manufacturers start using the technologies, you have a feedback loop that comes back and say, hey, you have not addressed this particular gap, and here are things that are pain points for us. Go back and feed it back into the system on the left-hand side where you're beginning to develop those technologies and fill those gaps, right? So we have a loop that's a pretty critical part of this whole ecosystem. So let me talk a little bit more about the platform itself.
Data access isn't the problem anymore. We've got all the data we can handle, more even. But how do we use data to create change and benefit from it without the context so necessary to create real value? The Sesame platform will dramatically reduce the cost and complexity of extracting meaningful, contextualized data from real-world industrial assets. By building data profiles of industrial devices and crowdsourcing extensive libraries of these profiles, we solve problems, simplify the complex, and drive innovation globally. It's plug and play for industry with all its industrial devices, machines, systems, and processes. Let's say that a system integrator in Chicago builds a particular robot profile, and a data scientist in California builds a predictive model for that same robot. The Sesame platform and marketplace now allows every manufacturer across America to access both that profile and predictive model and have their systems up and running in a matter of minutes. Harnessing the world's domain experts by giving them the tools to share their insights and obliterate the technology barriers so that data can flow and transform plant operations. A smarter, cleaner approach to manufacturing will lead to greater efficiency, increased productivity, and the ability to stay competitive in an ever-evolving global manufacturing landscape. Sesame, the Smart Manufacturing Institute.
So just full disclosure, the robot example was built into the video way before I knew that Jay was going to be here from the Robotic Institute. So, okay. So just very briefly, our membership, don't expect you to read this, it's on the website, but we do have a mix of industry, academia, technology vendors that make up our ecosystem and our membership. We have 102 members currently, and we are expecting that to grow rapidly in this coming year through our new membership model. So I'll just kind of flash these, and you recognize some of them, but welcome to, I think these slides are going to be available for the community. So my last slide was around, so all this stuff is great, but the reason you all are here is to find out how you can engage with the institutes and how the institutes can engage back with you. So I tried to articulate this in just one slide here. So the piece around technology development, I've had some conversations with a few of you over the last months, and found out that there are a lot of cross-cutting technology areas that the federal labs are working on that are very, very relevant for some of these institutes. And for us in particular, there are many programs going on in the federal labs that are directly connecting with either things like being able to predict things from a process, or high-performance computing, or specific areas of sensor development that are actually applicable for manufacturing. And those are all great things to have heard, because I feel like there's a great potential between the institute and the federal labs there. So if you look at things like cross-cutting technologies on sensing or modeling, that's certainly a piece on the left-hand side of this diagram. And then on the right-hand side is a piece that I think is sort of estimated and underutilized, which is that how do we take output of our institutes and actually go back and demonstrate it using the federal facilities that we have out there. It's a very powerful aspect of it. And the last piece is around the high-performance computing. As we think about the platform, there are many things that we need to leverage that are already out there. We don't want to reinvent them. So the ability to do high-performance computing as part of our platform is a strong connection as well. So hopefully these are just three examples of how I personally see the connections between them, but maybe there are other ideas that you might have that I'll be willing to share and discuss. So.
Okay. Well, thank you, Haresh. We'll save questions for the end. I just want to add to Haresh's last slide. You need thinking about what you have in your portfolio. It could be something like a new high-performance material that is high strength or survives high temperature or a particular caustic environment, and that could be something that might be useful for a particular sensor. That's way down on the edge of specific, but as you can see, there are companies within Sesame that are probably thinking about things like that. So being able to access the members of the companies, the company members of the institutes, is a resource that I would encourage you to explore. So next up, we have Jay Douglas, who's the COO of the Advanced Robotics Institute out of Pittsburgh, Pennsylvania.
Thank you, David. Good morning. There we are. Okay. Yeah, so you've got a pretty good introduction already about what Manufacturing USA institutes are all about. So very simply, our public-private partnership was created to improve U.S. manufacturing competitiveness through the use of robotics. That problem is directly tied to the workforce issue in this country today, where it's two fundamental issues. One is there's a skills gap, the other is there's a supply problem. If you go out and talk to manufacturers everywhere, they will tell you that they can't hire enough people and they can't find enough qualified people. So we're working in both of those areas. We fund projects on the technology side and on the workforce side. Fundamentally, though, more importantly, I think for this group here, is that we are a tech transfer organization. It doesn't do us any good to create the next greatest technology or workforce program if we can't get it into practice. Right now, we have about 20 people on our staff. We've been in business just over 2 years. Most of our people are tech transfer experts. So if you want to partner, we'd love to talk to you. More on that later. We do have a membership category just for federal labs. We already have several in our mix. So I'm going to talk a little bit about the problem that we're solving and how we solve it, and a little bit about what's going on in the industry. I'm going to skip over a couple of slides real quick because, interestingly enough, you've seen them already this morning. Anyway, so we have a particular focus on small and medium-sized manufacturers. A lot of the larger companies in this country are already well down the robotics adoption process, as well as working very actively at solving their workforce problems. But these are some of the key things. They just don't understand the technology, when to invest, what to do, what are the capabilities. It's changing very rapidly, and how do they keep up with it? So drivers of adoption of technology is that in this country right now, people are making things that weren't necessarily made here before, and we're not losing as many industries as we did in the past. But as one of my colleagues says, that if you could only buy what's made in the United States, you'd be naked, sitting on the ground, and unable to communicate. In that we don't really make clothing and furniture here like we used to, and we've never really made cell phones or computers. So we're working in all of those spaces to try to either reclaim or not lose industries. But the wage gap isn't as great as it used to be. American workers are some of the most productive in the world, and the energy position that we have right now, as well as the regulatory environment, is making manufacturing a lot more competitive within the boundaries of the United States. We really are at an inflection point. You're familiar with, often people use the term Industry 4.0. I prefer the fourth industrial revolution. And in Pittsburgh, we're kind of headquartered where the first two industrial revolutions took place in this country. And so we're really focused on the use of data and intelligence in the manufacturing world, not just the other Manufacturing USA institutes, but we in the robotics industry. It's very critical to where we are. There's a lot of things that have changed just in the last few years to make robots more accessible, higher performance, and in fact, quite more economical. Technology is converging. You can see on this chart where everything is changing, and it's also creating a pretty significant workforce problem. You can't just come right out of high school and go into most factories any longer. You can't come right out of high school and go into a coal mine any longer either. You're not really digging coal, you're operating a very expensive piece of machinery. The same thing is happening in many US manufacturing sites today. We don't encourage people to not go to college, but trade schools right now can very quickly prepare people at a much lower cost for a pretty great career path. If you study the right things and are able to work alongside a robot because of the skills that you have, that is a great way to have a really solid investment in a secure career. Anyway, so as I mentioned already, I think twice before, the convergence of technology and talent. Adopting advanced technologies in manufacturing isn't really possible unless you have the people to do it. Technology isn't really replacing people, it's enabling people to be more productive, and it's enabling businesses to be more productive. One of the things that we are seeing, which is an odd effect here, is that because of the shortage of workers, people that own and operate businesses are accelerating their adoption of robotic technologies because they just can't find the workers. But robots aren't really replacing workers, they're assisting workers. If you have a job right now that is easily replaceable by a robot or an AI system, you probably don't have a very interesting job. But training yourself to work side by side with these technologies is where workforces are going in the future. There is a real, I mentioned a very great human case for robotics. The two biggest industries in the United States that have invested in robotics are logistics and automotive. In the last 10 years, their workforces have dramatically increased because they become more competitive. And suffice it to say that if you're a business owner or operator and you're not doing everything you can to improve your cost, quality, and schedule performance, by definition, you're going out of business. So it's important, to stay focused on investing in technologies as well as your own workforce development. And those are some of the things that we're trying to stimulate. And again, it's tied directly to workforce development issues, investing in technologies. So, as we look at the future of manufacturing, I mentioned briefly earlier that robots aren't replacing people, they're replacing specific tasks. Robots, they still don't do what you see in the movies. There's a big difference right now between artificial intelligence and artificial general intelligence. If you watch a lot of sci-fi movies, we're not there yet, we may never get there. But what robots do really well is precise, repetitive tasks. And those are things that we as people don't necessarily do that well. We get tired, we get distracted. Robots don't get tired, they don't get distracted. Anyway, so it is increasing manufacturing productivity as well as workforce productivity when deployed properly, and we try to help people to do that the right way. So some of the keys to adoption, robots do need to become more versatile. A lot of the robots deployed in the last 30, 40 years are really only capable of doing one thing, mostly carrying a spot welder to a very specific point on the side of a car. But they are becoming more versatile and fungible, if you will, usable in different tasks. Time to deploy and repurpose is coming down dramatically. Cost of ownership, I mentioned, workforce readiness. Technology adoption is becoming a lot faster as we learn more about that as a discipline across all industries. Forgive me for turning to the side. It's the only way I can see the slides. We have done a lot of work in this space on technology adoption, specifically within the robot world. I used to work in a federal lab, this 5-step process. You've all seen it before. We work to apply these things to our manufacturing clients as well. Moving along, you've seen this slide twice now. We all use it. We're part of that group. Our membership is much like Haresh's. We have 197 members as of 4 o'clock yesterday. We have 9 different membership categories, from large companies to nonprofits to universities and federal labs. We love to have federal labs. There's no fee to join. You don't have a cost share obligation. It all comes under our TIA with the Department of Defense. But if you'd like to talk to us, you can catch the information on the website, or more importantly, just send me an email and we can talk about it. We invest in technology development, workforce development, and our national ecosystem. We have basically 9 hubs that we're creating around the country for technology deployment, and these are usually made up of an MEP, a university, and a couple of companies that have decided to band together to work on projects. This isn't our total membership, it's just some concentrated areas, and we think we have pretty good coverage across the United States for our ecosystem. Our members are located all over the United States, West Coast, South, quite a few in the Northeast, in the Pittsburgh and the Boston areas, which tend to be hubs of robotics activities. Seen this slide before. This is just a cross-section of our membership. We have large companies, aerospace companies, a lot of startups in the robotics field, most of the top universities in the robotics field, and our home base is at Carnegie Mellon University. We are co-located with the Manufacturing Futures Institute at CMU, where we'll be in 2 months when we move into our brand new facility, which has a lot of extra room in it if you want to get set up with us and CMU. The Manufacturing Futures initiative at Carnegie Mellon is focused primarily in additive manufacturing, which is a really nice adjunct to what we're doing. You've seen this slide before. We invest in TRLs 4 to 7 on the tech side, and more or less, if you could put that on the workforce side, it would be the same thing. We then work to mature the technologies and move them into a transitionable form. Our process is a standard two-step process of concept paper. It's evaluated then by teams of our members as well as ourselves and our government team. Then we invite you to provide a full proposal, and that's either accepted or rejected, and we fund. Tech side tends to be around $500,000 for 1 year. On the workforce side, it's more like $250,000 for 1 year. And that's basically the process. We are undergoing an experiment this summer to remove one of these steps. That would be the concept paper step. We want to try to accelerate everything. We're trying to get much, much faster to time to market. And so we're working with our government team to try to accelerate the proposal process. These are the key areas at a very broad level where we invest in technology. De-risking for transition to the factory floor, cobotics, human-robot interaction, interoperability, flexible retooling, and intelligent robotic systems. The introduction of the future of robotics is all about artificial intelligence, so we're moving that way like everybody else is. On the workforce side, the problems are generally very well known. The education system doesn't quite fit the needs of the manufacturing world. There's a negative impression of manufacturing. There's significant differences regionally in this country. Not enough workers in many places. In some places, unfortunately, there's too many. But anyway, we're working across the board. We're investing in some programs right now to bring underrepresented populations into the workforce. Women in particular, we have several programs going in that space. 50% of the workforce is women, but only 23% of the manufacturing workforce is. This is our first set of projects. It's an eye chart. I'm sorry about that. This is the first 18. We're launching 12 more in the next 6 weeks. We're doing lots of cool things. We're sorting fish. We are sanding helicopter rotor blades. We're building wiring harnesses. We're working with flexible materials. We're building cobotic applications that are being deployed in car companies right now. And we've got a whole new list of things coming down the pike, as well as a bunch of new workforce programs we're going to be launching this summer as well. So we're working across the board. We hope to have some of these set up in our building when we get there in June of this year for demonstration and further development. Anyway, that's me, that's us. Thank you for listening. I'm going to turn it back over to David for some questions, and we hope to be working with you in the future.
Thank you, Jay. So I think we have about 10 minutes. I'd love it if there were some questions. If there's some questions for these gentlemen or about working with MEPs or the other institutes, we could take all of those. Why don't you guys take that? Go ahead.
Sure. You want me to go ahead?
Go ahead.
You go first.
The answer is yes. The way it works with us is we fund projects and technology is created, and then it goes into our repository. For the IP perspective, the project team owns the IP, but they've agreed that they're going to license it to the other members of the consortium. As a federal lab, as a member of our organization, you could park your IP in our repository, which means we're simply going to promote it for you. You're not putting it anywhere. We would then promote it and move it out through our ecosystem. That's an example of how that might work. We have these companies all over the United States, and as I mentioned, we are fundamentally a tech transfer organization. We could almost, I don't want the DoD to hear this, so don't tell anybody, but if we just went around and collected IP instead of investing in creating it and then promoted it out there, we would be accomplishing our mission of impact and change. But what we're doing is trying to push the technology in areas where the community has told us it needs to go. But if we just went out and collected stuff from all of you and pushed it out through our ecosystem, that's just another way of scoring points. Okay, so let me, there's two questions here. Number one, if you want to work on a project with us, you have to be a member, okay? So let's take one of the more fun applications is this fish sorting thing we have. When it's done, they're going to have a robot that's going to be grabbing fish out of a conveyor belt that's going by and sorting them based on size and species. You have to, I could go on and on about the fish industry. It's very weird. But so they're doing this, and it's up to us then to get that into practice. So we're funding a project that's a robot that sorts fish. Now, it doesn't do any good for us to just have that and it's sitting in our facility. Not that we're sorting fish in Pittsburgh. You know, carp, I guess maybe we could, but no, we need to get that into practice. Okay, and that's by promoting it out through our ecosystem, having demonstrations, giving talks at conferences, making phone calls. You know, we're working very closely with the fish processing industry in the North Pacific and in the North Atlantic already in anticipation of this. That's just one example. When we talk about surface treatments, we're working very closely with 3M Corporation. Not that they own surface treatments, but they kind of sort of do. We're building wiring harnesses, and once we get that done, holy moly, everybody uses that technology. And we're going to be going to, you know, the airplane companies, the car companies, the watercraft companies, lots of places. So that's what we do. We fund projects, we create technologies, and then we move it into the community. Yes.
Then you do a call for proposals, and you have 18 proposals that you currently have funded and are working on. So those 18 proposals, once they're completed and so forth, those will be the ones that you will start promoting.
Right.
I just want to add one more thing. I think back to this last slide that and by the way, whatever he said about the ARM Institute applies to the institute that I'm representing. Same deal. The only other thing I add is some of the enabling technologies that I talked about, where if you have federal labs that are actually working on new sensing technologies or new materials or new modeling technologies, those then could become part of our marketplace, right? So he talked about a repository. I'm talking about the marketplace. Same concept. And so if there are things that we can do to help you as a federal lab understand what the needs are out there, we can certainly feed those back to you. If we don't have the resources, certainly you have them, and we can leverage it that way as well.
So,
I'm sorry, one question. So you focus on robotics, and you're just in general.
Well, we're calling it smart manufacturing. So it's sort of complementary technology, right? So here, when he talked about, I'll just use one example that he gave. How do you bring intelligence back into the robot? There are pieces of that are connecting well with what we do for manufacturing in general, right? So. Yeah, well, the specialty is called smart manufacturing. So if you talk about sensing, process control, process modeling, analytics, those kinds of things.
before we get to Ann's question, another thing to think about is before you have a technology, or before you've patented a technology, before you're actually doing the marketing, so at the point of doing pre-marketing, say you want to just test and see if this is actually a useful place to spend time. I know when I worked at MIT, this was always the question, is this going to be useful? And you have to look out in the future, and who knows. These are the gentlemen, the people in the institutes are doing that. Obviously, you may have to be able to, keep some things under non-disclosure or only mention general information. However, it's a great place to ask some of these initial questions. And it's my hope that some of those questions will just start happening, and as just sort of to raise the level of the collective intelligence of the group. That would, again, referring back to Dr. Copan, being able to get some quick wins and be able to mutually exploit the network for mutual gain. That's what we need to do to be efficient. You know, we want to reduce the amount of investment we make in these technologies and double the return. And so now, Ann, what was your question? What was that? Oh, okay, so your question was answered. Okay, so generally speaking, you need to be a member of any one of these institutes to apply for the project. The other thing that Jay mentioned was that he's willing to listen and hear about other new technologies that will further the mission. So if there are opportunities or there are things in the space that obviously he hasn't developed, but moving the process forward, being able to make things better for manufacturers is a terrific solution. And again, the last two things we talked about are sort of the technology push. The other part of this is, and again, thinking about quick wins, you have stakeholders today, you have companies that you're working with today. Perhaps they're suffering from workforce issues. Both of these groups, as well as the other institutes, are in the position to help your stakeholders get better employees in place. Perhaps there's one of your companies is having an issue regarding not just training the workers, but they'd like to explore robotics, or they'd like to find ways to make all of their processes work better. In those situations, being able to find out what's out there and implement a solution within that company that would probably end up working through the MEPs if I could make my magic circle of goodness work together exactly right. But that works for everybody. In that situation, you have an existing stakeholder who you're trying to help be successful. They are trying to help industry be successful. It's a situation where the pie does not get any smaller as you bring in new people, because we're all trying to get to the same thing, but we all have different ways of measuring this success. I think we have time for another question. Go ahead.
Hi, thank you. I have a question around, I'm really fascinated by the efforts that you have on workforce development. And so I'm just curious how much you're doing around kind of supporting, or whether you're doing anything around supporting entrepreneurship and innovation in the workforce through that.
I'll take a shot at it. We're just getting started around, like I mentioned before, that our workforce development programs are going to address each of these layers that I talked about, the people who are at the level where they're actually working and touching and feeling the process, and all the way up to the C-suite. And in the middle somewhere is this area where if there are people who are interested in developing new thoughts and new technologies that make up the system, how do you bring the workforce from those types of entities back into the ecosystem, right? So the thought process is that you can address that by also developing training or understanding of what these technologies are at that layer, and then have them become part of our ecosystem. That way they are kind of engaged in so a lot of the small manufacturers, but also the small entrepreneurs that can make up the system.
Maybe this is a more specific question then too, about whether there are opportunities, for example, concrete opportunities to actually do apprenticeships or internships with the small manufacturers or the startups that might be in your ecosystem. And if you're specifically funding or supporting that kind of development.
I didn't hear the whole question, but our first 4 workforce projects that we funded were to create apprenticeship programs for small companies, okay? The idea is that the BMW factory in South Carolina has an apprenticeship program, but boy, it's easy for them. They're a bazillion-dollar company. But what about the company that's only hiring 2 or 3 people maybe every 18 months? What do? They've got the same problems. And so our first 4 projects are coming off the line right now. We don't fund apprenticeship programs, but you could come to our site and get one of these programs to implement yourself. And so that was our first stab at the workforce issue in the industry.
Okay, I'd like to make a couple of summary statements really quick. Some you've heard before, but repetition does help. I think that the Manufacturing USA Institutes offer some distinct advantages for federal laboratories as they try and complete their mission. There was a discussion of being able to have, I believe that John mentioned it, being able to do better marketing and being able to communicate your story. Both of these are options from talking with individuals in industry in order to help refine the message and determine where the true benefits for your technology are. Again, along those same lines, I think that there's some really good opportunities to take horses that are already, trotting along and give them a little bit of extra hay and have them move a little bit faster to get some of these quicker wins. Move these companies along. If they've reached some sort of commercialization barrier, a manufacturing barrier, the institutes are in really prime position to be able to help you across a wide range of different industries. I mean, there's 14 different ones out there. For the most part, it covers nearly everything except for, I think, flat panel displays. And then just as some final reference points, it's an easy to find location for all the institutes, which is manufacturingusa.com, all one word. All of them are listed out, including their locations, contact information, areas of focus, anything you could probably want at that spot. And if for some reason that's not sufficient, you can always contact me and I will point you in the right direction. Sort of a fourth thing, along the way here in getting these companies into the right space, there is only so much that the institutes can do. They're not necessarily hands-on. The MEP programs are hands-on to help implement these new technologies. Now, the MEP programs are not technology marketing organizations, but they are company marketing organizations, and they are familiar with what's happening in the marketplace, and they can provide you great insight and great opportunities and help you also define what sort of benefits are resonating with their personal clientele. So with that, I thank you very much. Have a great day. There's a table with some of our information on it directly out that door, which I'll be at during the coffee break. I appreciate your time.